Hello guys, welcome our coding class. Before we talked about line tracing and how to follow the line. Today we solve the problem with obstacles, how our car detect obstacles and avoid them. In order to solve this problem, we will use front, left and right sides IR sensors. We talked about IR sensors and their values, making variables and local operators, and in obstacle avoidance task we will use all our previous experiences. So let's start guys. This is our main board, and you can see that left sensor, front sensor and right sensor. Now in obstacle avoidance we will use these sensors, and we don't need to use bottom sensor in obstacle avoidance task. So let me start. So go to the control and we start the start point hover, and we are creating for loop in order to check our sensors. So I created variables. Let me create again. I will delete. I will show you how to create. Before we created variables, so let's make again. Okay, left, right, make variable, front, and okay. For all scripts, click here. Every time you should keep for all sprites. And okay. So we have three variable for three sensors. So now we should set three our sensors. Left, set right. Let me change the front and right side. And in order to read our data value from our sensor, go to the link key and we should put analog reading here. Previous when we use bottom sensors, we used same one, analog reading, and here also using drag and drop. So we put all analog readings, and also we should set our sensors. So A0, A1 and A2. A0 is left side, A1 is front sensor, and A2 is our right. So let me put here, and so you can see that our right front sensors representing, if you click here, so we can see that our variables. So yeah, before you of course you should connect our link key. I already connected. Every time check this connection. Already linked, connected, good. And when we click this coding, on this code, or just click here, you can see the result. We are checking left, right and front sensors. For example, now we don't have any obstacles, and let me check the values of sensors. So you can see it's very high. And for example, if I put some obstacle in front of the car, let's check. Our front sensor value less than others, small value. And for example, if I change position of the obstacle like this, and we can see that left side sensor value also decreased. So, and let me check also right side. So now you can see that value of the right sensor also decreased. Now we know how we can manage our car using left, right, front sensors and avoid the obstacles. We need to check some conditions. Let me explain here. For example, this is our car, and when our car move like forward direction, and if our car detect the from left side some obstacles, in this case, like this, for example, in this case, our car should turn to the right side. When come here, it should turn like this. Turn and turn. Let me check here our sensor. Okay, when we go to the forward, and if we detect if our left side detects some obstacles from right, like this, okay, so it means that our car should turn to the right side, because in the right side we don't have anything, we don't have obstacles. So let me show how we can make this code. We need to go to operators and choose this condition. If our left sensor less than, I will choose 250 for the beginning. We will check again this one, 250, and if our left sensor less than 250, turn to the right side. So go to the link key, and we should give command for our DC motors. So set the DC motors, and in order to turn smoothly, we need fix like this 30 and give to the right side 10. And this is forward. We will set forward direction here. So this is our left side condition. It's the same step for the right side. For example, our right side sensor less than 250, we need to turn for the left side. So go to the operators, and again select this condition, go to the variables, and we should set our right side, and I will write 250. So if our right sensor less than 250 value, our DC motors get command turn to the left. Let me make this one, okay, 10 and 30 for the smoothly turn to the left side. So set the direction. Yes, this is our left side and right side conditions. So now we have another condition. For example, our car come to the corner like this. In this case, our left side and front side sensor get value less than right side. But how we can avoid this corner? For example, we can avoid using some rotation and go back and rotation using time delay. So how we can do that? For example, if you come to the corner, we will give some command back to the go to the back, then rotate after some delay, rotate our car, and after that we can see that our sensor get another value, so it will go to the another direction. So avoiding this corner, again go to the back, after some delay rotate, then go to the continue our movement. So let me show you this this part. So go to the control, take the if condition, then go to the operators. In operators we need some add operator. Add operator, put here, and also we need one more, because we have three sensors here. So and also we will use this condition and this one, and for the right side this one. Go to the variable. As I said, you left and front. If our corner for the left and front side, it means that we will put here like this, and we can fix our value here. For example, our front sensor, if less than 250 and left side less than 300 and front less than 250, and our right sensor more than 300. So in this case, go to the back, go to the linky, and we should put here our movement, backside movement, M1 and M2, our speed. Let me set 20, here also 20, 20, and direction, clockwise and counterclockwise. This is movement to backward. And after some we need as I said, we need to set here time delay. Let's give 0.8 seconds. After 0.8 seconds, we need to rotate our car. Again, we need to write our DC motors. We need to set our DC motors rotate our car M1 M2 and with 30 speed, and rotation, for the rotation we need to the right side, so counterclockwise and counterclockwise. Yes, and also we need to fix delay here. If we see here our rotation speed more than backward speed, so that's why we can set our time delay less than backward time, 0.5 second, and after 0.5 second our car will move following another condition. Through this condition we can say that we avoid our corner problem. It was the left side corner problem, and for the right side corner problem also we can use this condition. We can just duplicate this condition, duplicate, and click here like this. So, but here we need to change some variables. For example, right and left. So let me explain here. For example, our car, if come to right corner, we can see that our right corner and front value will be less than left side. It means that we need to go to the left side, so we need to go back, and after some time we need to rotate our car, and we can move following another condition. Follow the another condition. So like this. And here we need to change some variables. Yeah, we changed already, right and left. So next one is we need to change also our rotation direction. Rotation we will change for the left side. So here like this. That's it. This is our corner problem. Solution for the corner problem. In order to combine all our condition, we need if-else statement, if-else condition, and as you can see that we have three sensors, and when values of the sensors if less than 300 go to our if-else condition. So we need to write this this one. So let me go to the operators and choose the OR for the three sensor. Here we should put our conditions, for example, and go to the variable and fix the left side, right side, and front. For example, less than 300, less than 300, and less than 300. And let me put one by one. So first left sides, then right. Okay, and here our right. And be careful, you should put one by one, not inside the another condition like this. This is wrong. So we need to, every time we need to put like this, after one condition another one. And for the else statement, we should write default movement. Default movement will be only forward, M1, M2. Fix the speed and fix the forward direction and put here like this. So as you can see, we finished our obstacles avoidance task. We can run this one and you can see the result. Click here, or you can click here, start button, for example like this. Okay, so I will show you result also, but it works good. In order to stop our car, just change here to stop. So okay, yeah. In next class I will give you some mission, lane tracing plus maze escape. So thank you very much. Goodbye guys.